Okay, right. Evening, everybody. So I'll put even less effort into my slides than Kevin. Mine's just a markdown file. So. Yeah, well, thanks for all coming tonight and inviting me down here. Yeah, my name's David Betteridge. So for years I was a .NET developer, C#, and I think I started probably the preview version of C# back in early 2000s, whenever that was. And I used it right up to .NET 5, and I was always quite keen to use the latest version of .NET Core and so on. And then a friend of mine from university said, well, I've just started this startup and would you like to come work for me? And it's like, well, yeah, that sounds quite interesting. Only it's in Python. And so, well, I thought, do I do that? Do I switch? It's a bit of a switch because I feel quite comfortable in C# and it's like a complete different environment. But I took the plunge and so I had 3 months notice. I had 3 months in which to learn Python. And so I think some of you have probably done sort of the advent of code problems at Christmas. So that Christmas I decided to do them in Python and learned just enough to start the job, and then I've gone from there. So that was about 18 months ago. So I know lots about little bits of Python, but certainly not everything yet. So tonight I thought I'd go through the language, sort of show all the various bits of it, show how it's sort of the more interesting bits and how it differs from C#, and then we can go from there. So who's used Python before? I guess first of all, so some of you. Okay, about half of you. So would you say you're fairly proficient at it, or just odds and ends? Okay. Yeah. Okay.
Not a fan, to be honest. But
not a fan. Why's not? Yeah, why's that?
I think I can't get past the indentation as a sort of syntactically significant white space.
Okay.
That's what I struggle with. It sort of really stands apart from other languages.
Yeah.
Because of that. But you kind of got to use it if you do any machine learning.
Yeah, exactly. Yeah. Okay. And some of you haven't done any Python at all, is that right? Yeah, okay, fine. Yeah, so I'm hoping it'll be quite interactive tonight, otherwise it's going to be quite dull, me just going through every single part of the language, and I don't think that's that interesting. So yeah, just jump in at any stage and ask questions, and we can just go off in any direction we want, really.
I noticed a couple of links say online compiler.
Yes.
Surely they're interpreters, aren't they?
Yeah, they're interpreters, yeah. Yeah. Well, yeah, mainly.
Probably just inside compilers, I guess.
Yeah, there's like different versions of Python. The most common one's called CPython, which is an interpreter, and yeah, it's written C, hence its name. And so and that's the one we're using mainly tonight. Yeah, so which brings on. I mean, there's a few ways of running Python as well. If you want to do proper development on it from your machine, you probably install Python 3 from the Windows Store. So there's two versions of Python. There's 2 and 3. 3 is not backwardsly compatible with 2, and I think there's quite a lot of argument in the industry at the time when they brought out version 3 and broke everything. But they're on about 3.10 they're on now, it's the latest version. Yeah, so you can install that from the Windows Store and then use that in Visual Studio Code. You can install the Python extension as well, so that's quite straightforward to get going. You can do it online if you just want to play about with it. There's like a REPL thing you can try it with. Once you can also run it from the command line. You can do start, run Python. And you can also use a notebook, which we'll be using tonight from within Visual Studio Code, because it's easier just to demonstrate code. And that's what sort of data scientists use as well for their stuff. So who's used sort of the notebook things in Visual Studio Code in general? Notebooks. So a few of you, okay. For those of you, have some of you not seen sort of notebooks before? Or you've seen? Yeah, so you've got a collection of cells, and you can run them independently. In Visual Studio Code, you can put different languages in different cells as well, but we're just using Python and Markdown tonight. Yeah, you can run them in order, and if you declare a variable in one cell, then it will remember the value of the variable in the next cell, and so on. And so you can run it by clicking the arrow. So I'll just run the next one as well. Oh, no, just that one. Yeah, so I've just ran that cell there, and it's just displayed as output underneath. And you can run them in any order, so it prints the order you ran them in here. So I probably ran something earlier, so that's the second one to run. So it's quite useful to know that, because you can run them out of order and get confused if you don't pay attention to those numbers. Okay, yeah, so that's the most simple example in Python to get going. You don't have to set up any namespaces, classes, or anything to get started. So yeah, just print hello world as you expect, and the opposite of that is input, so you can take some input back in. So because I'm running it in a VS Code, it just displays on there, so put David in. Right, and then, yeah, so now we've got a variable called David, as you expect, and one of the things that they say about Python is there should be one obvious way of doing everything, but actually, you see that's not quite true. So this is looking at string concatenation, for example, so we want to concatenate the variable name with hello, and as you can see here, there's 4 different ways of doing it. You can use plus, which most other languages, you can do comma in the print, so you can do, yeah, sorry.
Do you have to install an extension to Visual Studio Code to get this, or does it just know from INB? File extensions, you just know what to do?
Yeah, you have to, there is an extension which is, I don't remember which one it was. Yeah, just Notebook, Renderer, and yeah, there's a couple of other ones to go with that. Yeah, that one as well.
Yeah. And presumably it has to be INB to get the notebook, otherwise it's just editing a file, right?
Yes, that's right. Yeah, that's the file extension notebooks. Yeah. So you install that, and then so within, I'll see it a bit later, but within Python you have environments, which is where you've installed your packages into. So you have to hook that up as well. So you have to get going.
Presumably you're in the Jupyter server anyhow.
You don't need to with the Visual Studio Code one. It just runs natively. Yeah, it's not quite. It's the Visual Studio Code. It's good, but it's a bit flaky in a couple of places. But for most things, it's good enough. Yeah, so you don't need to worry about anything like that. You can connect through. As you can see down here, I'm running a local one, and you can connect through to a remote server. But, the only thing we don't find it particularly good with at work is when you're doing live share, so 2 people working the same code base at the same time. It doesn't seem to work very well with the notebook, and we found it just keeps deleting the notebook and stuff like that. Quite a bit annoying. But certainly if you're working on your own, it's fine. Yeah, so going back to joining strings together, yeah, you can do a print statement and you can just do comma lots of different variables and it will concatenate them for you. You can supply it with parameters, so you can do %s and then have a list of things here which are going to be substituted in. All the sort of the newer syntax, which is still a couple of years old, is you put f at the beginning of the string and then you can just interpolate things within the string as well. So next one. So Python does have types, so for variables and so on. So we can see, right. So this example here, I'm going to declare a variable of type, which is going to be a string, and we're going to just print out what its type is. Then we're going to change the type of the variable to a number. We can print that type out. So you can see, name started out as a string, and then it quite happily then allowed me to change its type from a string to a number. Everything's a class, so everything inherits from an object internally, so strings and integers both do. So that's why it says it's of type class string, of class integer. So it's obviously not as strict as something like C# and stuff like that in terms of types, as in you can redefine them as you go. Okay. So statements. So this is going to get onto your hatred of indentation and so on. So yeah, so this is a sort of typical structure in Python. So you don't have brackets around your statements, but they do end with a colon at the end of the predicate. You've got doubles that equals, same as C#. So the block that's executed by that if statement, so instead of having curly braces or anything like that, is all indented. So it's normally a multiple of 2 or 4 you indents. So here, hi David will only run if name equals David, and then you've got else if and else, so it's if, same idea. So this line here will always run because it's not indented, so that's not part of that else statement. Okay, so I'll just run that. Yeah, I can't remember what I must have. Oh yeah, I changed up there. I've set name to be 12, didn't I? So it's hello 12, so it's gone down to there and then run that bit. Until recently, Python didn't have switch statements. They were added in Python 3.10 or 3.9, which is the latest version. So I haven't used them, which is quite strange because in C# I found I wrote switch statements all the time and sort of haven't missed them from not being in Python. Which is probably why they've only just been added not as useful. So while loops, similar idea to if statements really. Again, you've got no brackets around the predicates, but you have this colon at the end, which so whilst in C# you're forgetting to put semicolons everywhere, in Python you end up forgetting to put colons everywhere. And again, everything's indented that's going to run, so both of those lines are going to run every time around that loop. Yeah, to increase the variable by 1, you can't just do n++ or whatever. You have to do plus equals 1 or n equals n plus 1. See that running? So yeah, so for loops starts to get a bit more interesting now. So you had this range iterator you're going to iterate over. So doing for n in range, so that's going to give you all the numbers between 0 and 9. So it starts at 0 and it stops before it gets to that limit. Again, you've got the colon on the end and everything's indented. So that's going to print out 0, 1, 2, 3 up to 9. Oops. Right. I was hoping it'd be easy to use a notebook than just do it in code, but scrolling's a bit tricky. Okay. Can you see it when it's that low down? Is that right? Yeah. Yeah, so range can also take 2 parameters. So you can have a start number as well as an end number. So that's going to start from 15 and again stop before it gets to 20. See that? And there's a optional third parameter, which is, well, any guesses to what the third parameter is? Yes, exactly, yeah. So that's going to count backwards from 20 down to 16, I guess.
If you did print range, would you just print out, it's like a collection? Is range so you're returning a collection?
It's actually an iterator, so it's more like IEnumerable in C#.
Right, yeah.
Yeah, so other than that. Yeah, well, we can try that if you want. So we insert a new cell. So I'm not sure. I think it might print something.
Too lazy to do.
I think it prints something weird. So you get something like that, print range. Yeah, I think that'll do. Oh no, it tells you what the range is going to be. Okay. Yeah. And yeah, finally, if you're not interested in the variable, you just want this thing to happen twice or whatever, you can use underscore, which is like the convention for just discarding it away. We don't really care what that variable is. I can't remember if you've got that in C# or not. I know you have it in F#, but do you do that in C#? Yeah. You do, yeah. Yep. Okay, so onto lists. It's quite annoying. I can't actually just scroll to. Right, you're going to have to bear with it being halfway down the screen. So you don't really have arrays in. So in C# you've got the choice between arrays and lists all over the place. You don't have that choice in Python. Everything's a list, and a list is like a wrapper over the top of an array internally. So when you declare a list, it pre-sizes an array in memory, and then as you add items to it, it will just increase. Yeah, it will populate that array until it runs out of space, and internally it just makes it bigger again. But it's all wrapped up within this list. Yeah, so you can declare a list but with square brackets. So I'm creating a list here with 3 colours in it. You can append items into that list, so that's going to mutate that colours by adding a 4th element. And you can print out individual elements from there as well, so they're indexed from 0, just like C#. Let's run that bit. So you can see there, I'm just printing out the element of offset 1 or whatever, so it's green. And yeah, so you get you can do length of colours. So it's different from other languages where you're going to do like array dot length. In Python, it's len, and then it's a function you pass in the thing you want to get the length from. And we can show its type as well. So do both of them. So you can see it's got length of 4 because we started off with 3 elements and then we added that 4th one. And it just knows it's a list because we don't declare things as being a list of strings or a list of integers or anything like that. It's just a list of stuff. So that's all it knows. And similar to the range operator, we can iterate over the list and print out all the colours. Or could I? Yeah, that's better. We can, so as it says in that comment, as well as indexing sort of from the left, we can also index things from the end of the list backwards. So I think it's hat1, isn't it, in C# to go back a position, and it's -1. So that's going to give the last element we added, which I think was green or, yellow, isn't it? Yellow. So if you want to create a list of a given size, you do star. So you start off with a list with 1 element in it, and then you do like times 10, and then that will create a list with 10 of those elements in it. So it could be 10 lots of 0 in this example, or you can change that to be David. In case you have 10 of those. Any questions, comments so far? All good?
If you put random, if there's a random function, you put that in there, will it evaluate it each time and give some array of random numbers?
I don't know. I think not, but yeah. Randint. Yeah, unless I was unlucky. I'll just do it again, just in case. Yeah, there's we'll see this more later on, but there's a few things like that where when you first import your code, Python sort of runs it there and then.
Yeah, so it evaluates it once and then gives you 10 copies of it.
Yeah. So I haven't got an example of that, but a more interesting one is if you're providing a like a default parameter to a function, it will. The first time you call that function, it will evaluate that default parameter and then always give you the same value. So if your default parameter to a function was random int again, you'd get the same time every time you call the function. Okay. So we've got our list, but we can slice our lists up. So first of all, I'm going to create an array of letters A to Z, so we can see that. But one of the things about Python is there tends to be built-in class libraries for doing just about everything. So although it's easy enough to write in all the letters A to Z, it turns out there's probably going to be a built-in function somewhere for doing that. And in this case, it's in the string library. So I only actually came across this one when I was preparing this talk earlier in the week. So to use a library, you do import, which is like using in C#. So I'm going to import the string library, so I've got access to everything in there. And yeah, so it turns out there's a method in there called ASCII lowercase, which will then give us an array of letters. Let's run that. So you can see get the same thing. And you can also do help on these libraries to see what methods are available. Just about to see that. Yeah, so doing help on string then gives us sort of a little bit the comments from that library and a list of all the methods in that library, and also where the source code for that library is, so we can go in and look at that. So everything's either going to be written in Python or C underneath, and so then you can go in and see some of those methods as well. And yeah, you can see at the top there is where it's defined. Yeah, ASCII lowercase is just defined there, so it's as simple as it's just giving you that string. And yeah, so what else is on that? Yeah, that's probably it for that. Yeah, so we've got our letters A to Z. So then you can do ranges on that. So you can say, just get me everything from the start of that string up to the 5th element in the string. So A to E. So, and then probably as you expect, you can also give a start position, so do everything from the 2nd to the 5th element. And again, you can have a step as well. So you can go from the beginning up to the 15th, but missing out every other one as well. Which one was it? Which you can see there. So one of the things I found about Python when I started first using it is a lot of the syntax is straightforward, which we've seen so far. And then sometimes you get to these long lines of just like complete gobbledygook. You've got no idea what it's on about. So, I mean, one of the things I had no idea what this meant when the first time I saw it. So I don't know if anyone wants to hazard a guess what that does now.
Is it range stepping backwards one at a time?
Yeah, so which does what?
It's like
yeah.
First, start, finish, default, and then -1 step.
Yeah. So
I'm guessing.
Yeah, no, that's exactly it. So what it actually does is that then, so it in fact reverses a string. So I mean, I gave it a list there, but if I'd given it a string, it would reverse the string. So that's reverse. So
if you did -2, would it do every other one in reverse?
Yeah. Yes. Yeah. Have to check that then.
Everyone desperately trying to do the alphabet backwards in their head.
Yes, I was thinking, yeah, where's Y gone? But yeah. Yeah.
Backwards and missing out of it.
Yeah, yes. Right. And then, I can't remember why I put this example in, but yeah, so if you want to do string join, so to stick things together, it's the opposite way around to C#, I guess, in that you put your separator in first and you do dot join, and then you give it the things you're joining. So while C# you do, yeah, sort of string dot join. So that would give you something like that. And again, if you want to do that backwards, presumably you can just do that. Okay. So it allows you to write sort of quite concise code, which can be quite powerful, but obviously the danger is it's a bit like functional languages like F# and Haskell, where if you're not using the syntax day in, day out, it soon gets sort of quite hard to follow, and so it's not necessarily that readable. So obviously one of the strengths of C# and .NET languages is link, which we don't have in Python. So what we have instead is something called list comprehension. So the syntax is sort of very different from that, but you can sort of achieve the same results. So what's the best way of describing this? So we're going to iterate over letters. So that's our list of letters. And for each letter in there, we're going to do something with it, in which case we're just going to return that letter as an array. So this here is effectively not going to do anything at all. It's just going to give us back our list. So I'll just run that, show you. Yeah, so for each letter, we're just going to return each letter from that list. But instead of just returning the letter from the list, we can apply functions and do stuff to it first. So for each letter in our letters, we're going to return the uppercase version of it, for example. Or we can also add an if statement to the end. So we're only going to process letters from here. So for each letter in there, if that letter is less than M in the alphabet, then we can return it in uppercase. Yep, okay, so far. And then, yeah, we can then start, we can apply the same sort of slicing and ranging as before. So we can say, we're going to do things backwards. We'll process that list backwards. And so on. Okay. So hopefully you can see that can be quite sort of a powerful way of doing loops and so on without having to do, for range or iterating over things. Yeah, so a bit of a contrived example, but what we're going to do in this example is for each letter, if the uppercase version of that letter, because it was lowercase before, is less than M, we're going to return the uppercase letter. Like so, but yeah. Let's get rid of that. Oh, I hope you can see anyway. But the although it doesn't matter at all here, the problem here is we're recording this function twice. We can see that we're calling upper to evaluate each row, and then we're also calling the upper function when we return the record. So it doesn't matter here because it's not going to take any time. But if you imagine that's an expensive function to run, you might only want to do that once. And that's why you use this, what's called the walrus operator, which is colon equals. So what you do is in the if statement, you call your function and you assign it to a variable. And that bit in the brackets also returns the result, so you can do your comparison as before, but then use that variable when you're returning the data. So hopefully that makes sense. So again, now it starts to become sort of quite unreadable, I find, at this point, but sometimes you have to do it just for performance. And I'll run that just to show it works. And then the final sort of example in this section is you can do these nested loops. So what we can say is I've got an array, or sorry, a list of words here, and I can say for each word in that list, and then for each letter in each of those words, then I'm going to return the letter. Okay. As you can see now, I'm going to return every letter from every word. So Python developers like writing that on one line like that. Personally, I find it easy to read if you start to sort of break them up into multiple lines. Like so, it sort of makes a bit more sense to me. So it's like for each word in words, and then for each letter in that word, then I'm going to do that.
What do you have to do for your indenting now? Or just whatever you feel like?
Yes, in that case. Yeah, I think it's because it's a bit weird. It's because you're within these brackets, you can sort of put carriage returns in and do what you want. Yeah. Normally you can't just split a line anywhere. You have to put a backslash on the end. But because it's within brackets or a function call, you can just put wherever you want. And again, because we've got square brackets around, sort of the result, the answer comes back as a list. So we're making a list by doing this. Right. Is that making sense to everybody so far? Yeah. Are you finding this helpful or not, or do you want to go in different directions? Yeah.
Yes.
Okay, good. I'll keep going then. Okay, so the other sort of main built-in data structure you have rather than list is dictionaries. So that's name value pairs, just like in C#, JavaScript, so on. So this is one way of declaring a dictionary. So I said, David's in York, Kevin's in London. So that's the key and that's the value. Again, we can do the length, which we're going to get back a length of 2, hopefully. And we can look up elements from the dictionary by the name. So pass in David, and we should get York back. We can check whether keys are in the dictionary. So the syntax is in. So if David is in dictionary, we'll print that. And you can do the inverse, which is not in as well. So Frank not in dictionary. And that does hopefully what you'd expect. You can also iterate over all the keys in the dictionary. So for name in a dict, so that's going to give you back wherever you set as your key. So that's going to be David and Kevin in this case. And then we can look at the value. So the shortcut for doing that. So instead of just return, if you find you're doing a loop and you return the key in order just to look up the value, what you can do instead is when you're iterating over, do .items, and that will give you back both the name and the value at the same time. So you'd have to go off and look up the value. So yeah, I've done that. So you can see that gives us back what we want. And the thing we're getting back has a type of a tuple, so it's just a pair of values. So yeah, so tuples are quite common in Python. They're sort of passed about all over the place. So back to our example a minute ago where we were returning a list from our letters. So we don't want a list, we want to have a dictionary come back instead. So the syntax for that is instead of using square brackets, we use our braces, and then we say what the key is, colon, and then its value. So that's going to produce a dictionary of letters being the key and the uppercase version of the letters as the value. And yeah, we can print that out. Okay. And yeah, so as from Python 3.6, I think it is, things in dictionaries have the same order. So if you insert them in particular order and you iterate over, you will get them back in the same order as well. And because internally it just keeps two lists, it keeps a list of values and a list of keys, so it can do that. Does everybody know why you'd use a dictionary rather than a list? I guess would be you. Speed. Yeah, exactly, speed. Yeah, so you can do. Hashing the key. Yeah, exactly. Yeah, so yeah, typically to find something in a list, you have to iterate over the whole list. With a dictionary, you can go straight in. Yep. Okay, yeah. So what should we do here? Is there anything in Python people want to see in particular, or I just no burning questions? I think. Or okay, I'll just keep going on, shall I? Okay. So yeah, sort of. I mean, if we're doing this interactively, you could do this as an exercise, but we'll just go through it now. So imagine you've got some text, and you want to know how many A, B's, and C's are in that string. So one way of doing this is we could declare a new dictionary. So this is another syntax for creating a dictionary. You can say dict in brackets, that's an empty dictionary. And then we can, what I was doing? Yeah, okay, yeah. So for each letter in that text, so we'll start off with A. Is that already in our dictionary? If so, we can add 1 to its count. Otherwise, we'll add it to the dictionary with a value of 1. And then we can print out the counts at the end. So hopefully that makes sense to everybody. Yeah, so if it's not in the dictionary, we add it in with a value of 1. Otherwise, we increment that count by 1. Oh. I'll have to run that cell first. So we can get back our dictionary here. So we've got 12 A's, 9 B's, and 12 C's. So that obviously works. But in terms of Python, that's quite a lot of code to write. For some reason in Python, we was trying to write as little code as possible. So, and one of the reasons there's a fair amount of code here is because we have to check whether something's in the dictionary, and then we've got a slightly different case whether it's in there or not. So we can shorten that by using a default dictionary. And a default dictionary, you can give it a method which will give you an entry if your key is not in the dictionary. So if I say, give me the count of the letters A from the dictionary, it's not in there, it will just call a function called integer to give me its default value, which will be 0. So if I say, tell me how many z's in there, it'll just say 0, rather than give me a key error. Which then means I can just loop over each letter, and if I find an A, I just say, get me the count for A and increase that by 1, and so on. So I don't need to bother checking about if it's already there or not. And you see we get about the same answers. Does that make sense to everybody? So yeah, so that's obviously quite a powerful thing to use as well, so you don't have to keep checking to see if your key's there. But it being Python, again, it turns out there's already a built-in function for doing this. And there's a counter class in the collections library, and you give it the text, and it will automatically give you a dictionary of these counts. Right. On to functions then. Another keyword to learn is def, which defines a function. You give it a name. So the convention in Python is lowercase for function names and underscores. And then you list your parameters, and again, you've got a colon at the end. Everything in that function is then indented, and you have to explicitly say return to return a value. If you get to the end of the method without having a return, it just returns none or null in effect. So that defines our function, and then we can just call it as you'd expect, add 1 and 2. Which is quite happily giving us 3. Down here, I'm also going to call add with hello and world, because we haven't said it takes integers or numbers in as parameters. So as long as it's 2 things we can add together, it's going to be quite happy with that. So hello world. However, if we give it a mixture of things, a string and a number, it will error. So although, Python's quite relaxed when it comes to types, there are things you just can't do. You can't add a number and a string. So it's, I don't know, I would argue better than JavaScript in that respect.
Well, JavaScript wouldn't even care how many arguments you get.
No.
Which is something, isn't it? But otherwise, it's not really strongly typed at all, is it? The parameter, you can't. Is there a way of saying I want an integer as this first parameter?
Yes, I'll show you that in a second. They're called typing hints.
Right.
So it's very much it's not so much I want, but I would prefer.
Recommendation.
Yes, if it's not too much trouble. Yeah. And just finally you can. Yeah, so as you expect, if you pass into integers, we're going to get back an integer back, and if we pass into strings, we get back a string. It's probably what you'd expect. There's not much else to say about classes really than that. You can return anything from a class. It doesn't have to be a single value. You can return a tuple. So tuple, just put things, comma between the 2 values. Or you can return dictionaries, lists, and so on. You don't have the concept of passing things by ref or by value either. You just give it stuff. So classes, next one. So all classes inherit from object, although that happens by default. You can, when you're declaring a class with the class def keyword, you can put what you inherit, what your base class is, object for example. If I'm honest, I think I very rarely had to inherit from anything in the stuff I've been doing. We'll see a version of interfaces in a minute, but again, you don't really use interfaces either because it's not fussy about stuff. So so declare a class with the keyword class. You can have brackets if you want. You don't need to have them, and then colon, and then everything indented, as you'd expect, is then part of that class. You must have an implementation. If you haven't got any code to add to your class, you can just put the word pass in, which just won't do anything at all, but it just means it is a valid implementation. Likewise, when you're declaring a function, you can use pass if you haven't got a body for the function to write yet. So then you have some sort of magic sort of methods in C#. And they're these ones which have got double underscore before and after them. So they're sort of names it expects to have. So init is a bit like a constructor in C#. Whilst in C#, the constructor runs as the class is being created, init runs sort of after the class has been created in Python. So it's subtly different. All instant methods are passed in self, which is that class itself. So here what I'm declaring is 3 instance variables. So I'm saying self.owner is owner that's supplied color and length in meters. And then within that class, you can then add normal instance methods, so start engine and stop engine. You can override things. So like in C#, you can override toString when you're printing stuff out. You can override str and return, and that expects you to return a string. And there's 2 versions of that. There's like a user-friendly string and a more sort of a detailed string you can return. So that's the user-friendly one, and that's the more sort of detailed one. And you can also override length for any object as well, which is __len. So when we were earlier, we're doing print len of list or len of dictionary, it then calls this len method. So as we see down here, we're going to create 2 instances of the car, the default values, and then we can print out like owner, and we can also use the len method.
What's the arrow string for?
Arrow string.
Representative.
Oh, sorry, yes, I shouldn't have added that in yet. But yeah, that's a typing hint. So yeah, so that means we're expecting this method to return a string. You know.
Where do we get that? Is that one of those fonts that, what do you call them? Ligatures, yeah. It's presumably a hyphen.
Oh yeah, that's a good point. Yeah, it is, isn't it? Yeah, it's a yeah. So I'm so used to using that font that yeah, because like the font gives me like yeah. Oh, you don't get with double equals, right? Yeah, not equals, does it?
Yeah, it's pretty.
Yeah, yeah, it's one of those things. So I've always used that font for like 18 months, and then other people come along and see it and go, "What you've done there?" And it's like, "Oh yeah, I noticed that." Yeah.
And then one day it's not there.
Yeah. Or it's like I use the AI code thing in Visual Studio Code to help you code as well. And when I don't have an internet connection, it's like, what's going on? I have to actually write stuff in.
I don't know how to code it.
yeah.
It's like look at that and think, oh, it's an expression body, but then also you've got implementation. It's like, what?
Yeah. Yes, so
it's off, isn't it? Now you've got CodePilot off.
yeah, I've got no internet at the moment, so yeah, otherwise it it can be a bit annoying sometimes as well. Like if you're doing demos and stuff, it pops up.
Just go
Yeah.
away.
Yeah.
You can switch it off.
Yeah. Oh yeah.
But,
Yeah.
But who can be bothered doing
Yeah.
that? When
Yeah.
you complain.
The other one that's annoying if you're doing coding puzzles as well, because it comes up with answers, and I don't want the answer. I want to do the puzzle. Yeah.
Fibonacci has done it.
Yes. Yeah. So here I can access an instance variable from my class, and here it's printing up the length because when I created the class, I said it's 2 meters long, and so I'd overridden the len method, so you can do that. Yeah. So we've got a couple of methods on there, which when we created the class a minute ago, which was what was it? Start engine and stop engine, which we can call. But because it's Python, it's all quite dynamic. We can actually scroll up slightly. So what we can also do is we can create a new function called break car, which is going to print car is broken. And then on one of those instances, I can now just go in and overwrite what that function is. So for Rebecca's car, so my wife's car, I'm going to say, well, when you call start engine, instead of calling that method, which we originally had when we declared the class, we're now going to call this break car version. So we run them. Yeah, I wondered that when I was coding this up actually, but no, it seems to no. Yeah, I was a bit surprised by that myself. Yeah, I think it's to do with your changing like the instance of the class rather than like the sort of actual definition of the class. I think that's the difference. So it knows what you've.
It reminds you of the prototypal inheritance you have in JavaScript, isn't it? Just override
Yeah.
things.
Yeah, so so this is quite an extreme example in that I've got the same class, but the start engine method now does different things on those two actual implementations of those classes. So obviously that makes mocking quite straightforward in testing, because if you've got a function that goes off the internet to collect some data, you can just override that one function, and then becomes your mock. So yeah, that's how I tend to do it. I tend to have I have a really small function in classes which I want to mock, and I call it something like patchable, and then I know I can just overwrite it in my test if I want to. So here we gave it a function which we had defined. We also have lambda syntax in Python, so sort of anomalous function sort of idea. So here they actually use the keyword lambda, and then you can have arguments as well, and then colon, and then the implementation of that method. So see that? So again, I've just overridden that method. Yeah, I think that's probably all there is to say on classes for now. So the next sort of strange one when you first start looking at Python is you see sort of some methods which take arguments like this, which is like star args and star key KW args, and you think, well, what's that mean? That makes no sense at all. So args are a bit like, is it params in C#, where you can just list any number of parameters and they just turn up as an array. So that's your first one. And KW args are same idea, but you can also give those parameters names. So probably best to see from an example here. So here I'm going to call my method a method, and I'm going to pass in 1, 2, 3. So they all get matched with these arguments because they don't have names. So they end up in a list called args. And then I'm also going to provide a couple of named parameters. Name equals David, city equals York. So they're going to end up in this list of keyword arguments, which is then a dictionary. Like so. So actually I might just print the types as well. Oh, so, okay, yeah, it's a tuple rather than a list. But you get the idea, so you can provide any number of arguments to your method.
Presumably the args and the keyword args is just what you call it, it's the star and the star.
Yeah, exactly, yeah. Yeah, it's just the convention is args and keyword args. Yeah. So I use that quite a lot in unit tests. So when I'm setting up my tests, I'd have a method which is like given a customer, and then I provide values like name equals David. So you can then choose what values you want to supply when you're creating that customer, and then I just loop over those, put them into the database. So the other thing you can use stars for is decomposition of tuples. So an example here is I'm going to create another method that just takes in 2 arguments, name and age. And then I'm going to create a tuple. So that's how we create our tuples. That's got 2 values in. And then when I call that method, I take the first element out of the tuple for the first parameter, the name, second element out, which is 46 for the age. So that's as you'd expect. But you can also use this sort of star as a sort of decomposition. So that will automatically do that for you. So it will split apart that tuple and fill in the gaps.
Destructuring.
Destructuring, yeah, exactly. And you can use star there as well if you had named arguments to your method. Okay. Now on to the more interesting typing hints, which I think for C# developers is more the thing. So as we've already seen, we can declare a method here which takes in some text, and I'm going to take I'm going to capitalise it. So take the first letter, turn it into capitals, and the rest of the string into lowercase. And so we can call that for David, and it's going to work. And we can call it for 1, 2, 3, and it won't be any surprise that's not going to work because you can't do like dot upper on a number. And so you get a runtime error. You just can't do that. So the problem there is obviously we don't like runtime errors. Ideally you want to catch stuff in the IDE even before you build your code. And so obviously that's not getting caught there. So what we can do is we can add something called a typing hint. So a typing hint is, think of it more as an IDE thing to help you really. So it's saying, when you call this function, I'm expecting you to give me a string, and I'm expecting to give you a string back. Okay, so it's not going to stop you calling it with anything you want, because we don't really have this compilation step as such. But in the IDE now, we can see, well, what we're going to call that now, it's now complaining, because we're giving it something that it doesn't think is a string. So I think sort of, again, there's quite a lot of complaint in Python when this came in as well. A lot of people didn't like it because I think they thought it's sort of taking away from sort of the simplicity of Python a bit. But it is optional, so you don't have to use it.
It's fairly recent that got added to the language.
Ish. I mean, it's becoming more and more popular. Every version of Python builds on these typing hints, and so you get more and more support.
It's just like TypeScript, that style of typing.
Yeah.
Colon and then the type.
Yeah.
Or is it the other way around? I think it's the same. I think it's that way around.
Yeah.
Do you know what tooling is used to work out the types here? Because obviously VS Code is doing some type inference behind the hood.
Yeah, there's so VS Code uses Pylance is the tool for that one. There's a couple of different. There's Pywrite as well, which is another one.
So does that do inference in the sense that if you don't put a response type on it, it'll look and go, like on the capital letter C, if you remove the arrow string, will it go, well, you return a text on this, so when I run the validation and you try and treat it as a number, it will tell you.
It will, yeah, so you can see there I've removed the turn type, and yeah, it knows it's a string. It's inferred it's a string coming back. Yes, and then yeah, sometimes it then helps downstream, and other times you do have to go back and explicitly put the types in. So, my personal preference is whenever I declare a function signature, I always put types in. I've always worked in that way, so I've always wherever I'm writing code, I write the function signature first and then sort of plug the bits in afterwards. Within the actual implementation, I try not to put any type definitions because most of the time it works out and it's just clutter. Yep, okay, so that's... So I've got another example here. Right. Yeah, so the example here is we're going to give it some text, and if that text is none, which is the same as null, in other languages we want to return empty string, otherwise we return that text. So again, we want to add type signature for that. So that's what I found. I'll do it up here, in fact. Yeah, so we want to be able to call it. Oh, yeah. Right, yeah, so your first thought would be to add the type signature has just been like string to string as before. But the problem is that's not valid because we are going to allow you to pass in none. So that's one. We're always going to return a string, but the value we pass in could be null. So we have to also say it can be null. And the way we do that is we use optional. And I'm not sure I've included it somewhere. Yeah, so in order to use the optional keyword, you have to import it from the typing library first of all. So you do from typing import. Oh, I've already got a function called that. Yeah, that. So hopefully that makes sense. So so we're saying we're going to take a parameter that's a string, but it's optional, so it can be none, can be null. So that's fine. But the thing we're going to return back can't be none. And
Should be string question mark or something in other languages.
Yeah.
Wouldn't it? Null type.
yeah, exactly. So the way the way optional is actually implemented is there's also a union command for types. So actually it becomes union none, comma. So that means the same thing. So it will quite happily accept anything in this list, in this union. So you could have union of integer, string, none, if you want to take either. Does that make sense to everybody? Okay. So that obviously becomes quite powerful being able to use unions over types. So that's something that's a bit harder to do in that sense in C#. Let's skip that one. Yeah, so the next one, which I quite like, is yeah, so sort of a common bug, I expect for everybody, not just me, is you've got a method that takes a couple of parameters which are both integers, so we can print person and address, and you set up a couple of variables and you call that, and you accidentally switch those parameters because they both are integers, so the compiler's not going to help. It's quite happy you've given it an integer, you've asked for an integer, so that's all going to work fine. We can run that. So you can see it said person 5678 instead of David, which is 1, 2, 3, 4. And the way you can get around that problem is you can create new types based on existing types. So you can say, actually, I'm going to create a new type called address ID, which is based on an integer, and another new type called person ID, which is based on an integer. And that's what I'm going to accept into this function instead of our ints. And so, yeah, down here, when we declare them up, I'm saying David is a person ID, York is an address ID, and now it won't let me pass them the wrong way around. So not only does that make it harder to introduce that type of bug, it also sort of helps document your code a bit as well. I found that quite useful. Okay, all happy with that? Yeah, however, yes, I was doing some tests on this last week at work, so I've been performance tuning some code, which it's taken hours and hours to run. And it turns out creating these new types is a very slow operation, so it doesn't come for free.
You'd think it was just sort of a compile time thing.
Yeah, that's what we thought. Yeah. Yeah, so if you're doing tens of thousands of them in a loop, it's not good.
So essentially, is it creating, in a sense, a new class called address ID, which inherits from integer and output? So if you did like a type of...
Yeah, I've got that down here actually. See, yeah, these are the types coming out here actually. They're still ints. So it is just a compiler thing. So you'd think the IDE could almost just replace it when it runs. So I'm not sure why it is so.
Optimize everything.
Yeah.
Was it the slow bit like defining the new types, or if you when you do like new
It's
version?
yeah, it's the defining the bit. So it's where you were doing. Where's it gone? Yeah. Yeah, like this line here. So I'm having to effectively cast an integer into a person ID, and that was slow.
Even though that's a no up.
Yeah.
It's slow.
Yeah.
So even though it's an integer anyway.
Yeah. Yeah.
When it comes back.
Yeah. So the solution for us was once we fetched the data from the database, the first thing we did was just replace integers with the proper types, and then it was already in the right format everywhere else in the code. Yeah. Just don't keep doing it the same one time again.
It's quite funny that it's slow when the underlying type is an int.
Yeah.
Because you can understand it if it's just putting a box around an int.
Yeah.
You'd have to do it in C#.
Yeah.
You can understand then.
Yeah. You'd think it would like compile away to just be like an identity function and not do anything, but it certainly didn't. So. Python has a few quirks like that when it comes to performance, where things that look things are completely obvious and then can be really slow, and other things are quite fast. So interfaces next. So yes, don't really use interfaces in Python. I mean, I guess they're used a lot less in C# than they used to be as well now. But so the closest thing you have is something called a protocol, really, when you're using typing hints. So what you can do is you can create a class and you can inherit from a protocol, and then you can give it your signature of the sort of the abstract signatures you need, and then instead of giving it an implementation, you do 3 dots. So that says it's sort of, this is like your abstract method you're going to have to implement. And then, when you do your implementation, you just declare it with the same signature, and then that's it. Now you can create a method which takes in something of that interface, so database access, and it'll be quite happy then to be given something of this type memory access because it matches that interface. A few confused looks there. Yeah, so when you're declaring that method, when you're actually doing the proper implementation, you don't need to say, I'm inheriting from that or I'm implementing that. It just works because it does match the signatures. Yeah, I mean, it does it here as well. So if I, rename that. So you can see it went red down here because now memory access no longer has a method called getPerson. So the IDE will stop you.
So the protocol isn't defining a specific implementation of an interface, then that's just saying when this is called, just make sure I've got the same functions as something.
Yeah, yeah.
It's like defining a signature. Well, like an attribute as a charge.
Yeah. There are sort of runtime ways of doing it as well. So at runtime, you can say, I've been given this class. Can you just double check you've got this signature as well, which is slightly different. But yeah, I've done it in a few places, but I haven't had to do it much. So next one is generics. So similar idea to C#, but probably not quite as powerful. So where you put the thing that's going to be generic in like angle brackets in C#, you sort of declare on the line above, you say, I'm going to have this generic called T, and then this method, I've got 2 arguments, and they're both going to take things of type T, and I'm going to return something of that same type. You don't have like, in C# you can then follow that with a where clause. You can say where T is the class that implements from something. You can't do anything like that, so it's a bit more limited in that sense.
I suppose that to a certain extent that doesn't matter so much because you're not type safe in what you're doing. So basically it accepts any T at this point, yeah. Is the T at the start of that declaration and the T that's actually in the type file?
I think they have to match, yeah, I think so. I keep meaning to check that, but yes, certainly everyone always writes them matching, so I think they have to. Oh yeah, I haven't actually mentioned this. If you want to do like an inline if statement, the syntax is the opposite way around to C#. So if the if statement matches, it returns that bit. So I'm going to return first if first is not none. Otherwise, I'm going to return second. So it's like the opposite way around to C# Java with the question marks and the colons. So I think it sort of makes more sense. I don't know if many of you said that mathematical notation where you have like the big open brace, and then it's like I'm going to return X if this is true. I'm going to return Y if that's true. So it sort of fits a bit more sort of that syntax. Right. Any more questions about type hints and stuff like that? I guess that's quite a big topic.
It's like a generic, except because it's not strongly typed. You don't really need generics, do you?
Yeah, again, it's just a hint to the idea. I mean, you could write that function, obviously, without any type hints at all, and it can't really work. But here, it just means that when you're calling it, you know, the thing I'm passing for the same parameter has to be the same for the second
So
parameter.
if you start like coalesce string,
Yeah, exactly. It will complain. Yeah.
Compile it.
Yeah.
Quite easy.
Yeah. Okay. So, right. Okay. This is probably the most complicated part of the talk. So here it goes. So decorators. So I'll explain the differences a bit more in a minute, but decorators is probably the closest thing to attributes in Python. So what we're going to do first of all is, so unsurprisingly, we'll start off with something simple. We're going to declare a function called 6, which is just going to return the number 6. And we're going to declare a function called double, where we give it an integer, and it just returns a double that integer. And as you can expect, you can compose those functions by just, calling one after the other. So that's going to give us back 12, hopefully, which gives us back our 12, which is no great surprise. They'll just need to delete it, so we're just going to get rid of that function out of memory. So we're starting from scratch. So next example, part 2. Right. Same idea. We're going to have a function called 6, which is going to return our integer. So we'll put some type hints in this time, so 6. And we're also going to have a higher order function called double, which in this time, instead of taking an integer, is going to take in a function. And we're going to call that function and return twice its result. Okay. So here we're going to say, we're going to call the function called 6. So that's not the number 6, that's a function called 6. And we're going to then return twice that. So we should still get back our 12, which we do. The type hint for a function is callable, and then that's its parameters for the function, and that's what it's going to return. So here, double can be called with any function that's going to take an integer as a parameter, and it will return an integer, which is fine. Right. That's not right, is it? Sorry, that's not right. Doesn't take any parameters. That's better. So when we call it with 6, 6 doesn't take any parameters, so it takes no parameters, but it returns an integer. Okay. Right, getting a bit more complicated now. So a function can also return a function. So here, when we call build double function, all that's going to do is internally it's going to create a new function called double and return that back. Okay, and then, so when we call it, we call build double function, which gives us back our function, which we're then going to pass 6 into, which it will then double. So this will all become clear as to why we're doing this in a second.
Not return double.
You could do, but I'm just trying to build up to,
Okay. So why not returning yourself?
oh, sorry, did I do it wrong? It could. Yes, you are right. Yes, sorry. Yeah. It's my fault for renaming the function to a meaningful name. That's better. Right, thank you. Yeah, so that returns 12. Okay. And then yes. So the next more complicated example again, so we've got our function 6, returns 6, and just remember what this one does. So this double, we now give it a function, and we return a function that's calling that function and doubling it, which now starts to look a bit weird at this point. So that will give us back a new function called double 6, and when we call it, it will then invoke all the functions and give us back 12. So this is getting quite wacky, as you can see. So that's 12. But the advantage of doing that is if you can get your function into that shape, you can then just apply it to the top of an existing or any other function using an @ sign. So that's a bit like your attributes, but these are decorators. So what I'm going to say now is if I put double above our method called 7, it means whenever I call 7 now, it's going to first of all call our double function, pass in that bit of code, and then run that within there. So now all I'm saying is I haven't changed what this 7 function does itself. All I've done is I've added this decorator to it. So it now can return 14. So although double's not a particularly useful example, you could imagine you could have something that does timing for a function. So you could have a decorator called time, which you apply to the top, and then it could work out what the current time is, run the function, record the time now, and say, well, this is how long your function took to run. So you can do all that sort of stuff without having to actually modify your function itself. So yeah, so don't worry too much about the steps we went through to get there. It's more, that's the point, is a decorator is a function that can be called when you call another function.
How would the arguments that get passed into the decorator? So if I call 7 with, like 42.
Yep.
Do the arguments get passed to the decorator, or do they get applied to the body of that method, and then that gets passed to
You
the
can
decorator?
do both. You can either pass arguments in there, and you can also call it at this point with arguments as well. And and then that's nice 4, isn't it? So in which case they appear either here as extra ones or there as that function as well. And there's some clever tricks you can do around that as well. So I've got another example in a second, actually. We'll just shoot on to exceptions quickly. So in C# you obviously got try, catch, finally. In Python, to be slightly different, you've got try, except, finally. It's basically the same idea. You do try, everything's indented, colons indented, and you do except rather than catch, and then the type of exception you want to catch, and you can catch into a variable as well if you want. And exceptions can be thrown based on other exceptions, and you can re-raise them. So nothing really any different from C#. Here's another example of a decorator I wrote for the talk here, which we can map a function with must be positive, and it's going to call a function, and if the result's less than 0, it's then going to raise an exception. And then we can just apply that to, subtract, for example. So I've got a method a minus b, so I'm saying that when you call that, the result must be positive. And you see the second time it runs here, because 10 minus 50 is going to be negative, it then raises the exception. So all we've done to do that is, just added the decorator to the top of the method. Again, I don't think that's particularly good use for a decorator, but it sort of shows the type of thing you can do. Okay, any questions around that type of stuff? I mean, you can use decorators to give you sort of metadata in the same way as you can with attributes, but it's a bit harder because you have to store that somewhere, because it's this function that's going to be called. So if you're using it to add some extra data to your method, you need to store that in a dictionary or something. It's a bit more complicated. Okay. So the next, big new thing for Python, I guess, is data classes, which is, I guess it's similar to how records have been added to C#, and so Python now has these things called data classes. So before, as we saw, if you're declaring a class, you have to provide all the parameters in the initializer. If you want to have it print out nicely, you have to either overload str or rep r. And if you don't do that, which I haven't done here, when you print out that class, you're just going to get rubbish because it doesn't understand how to display that class. So what you've got now is you've got something called data classes. So you can import data classes library. And when you declare your class now, you can say it's a data class. And you can just list your variables and their types. So you have to give it types at this point. And then when you construct that class, you can just pass in the types as before. You can change the value of color, for example, if you want to. And now when we run it, change the color of color, so it comes out as blue rather than red. And it's going to give you an overload of rep r for free and things like that. And you can do equality between classes and things like that for free. So obviously that's mutable at the moment because it was quite happy to allow us to change the color. What you can do is when you create it, you can say it's frozen, in which case you can't change any of the variables now. It's now an immutable record. So now you can see it now complaining. We try and set color to be blue after we've created the class. So you get this, yeah, cannot assign to field color. You've got a bit more control as well. So this sort of abuses the lack of types in Python slightly to do this. So when you're declaring these fields, you can say, well, the owner, for example, you don't need to pass it to the initializer. So when I initialize the class, I don't have to give it owner. And when I print out the details of a class, I'm not going to include the color. So you can do that by supplying this sort of field information. But obviously the slight abuse of Python here, which it's quite happy about, is I've declared this field of being type string, but when I'm creating the class, I'm actually setting equal to a field, which isn't a string. But it's quite happy because that's just how it uses it to get its data. Does that make sense to everybody? And then, yeah, down here you can see it's missed out color because we've said not to include that in the output.
Can you freeze certain fields as well?
I think so. I don't know actually.
It's a bit of a weird record, but
Yeah, I know. I think there's. I know you can give it like defaults and things. But, no, you can't. You can. No, there is some weird hack around that, but no. Right. Yeah, so that's data classes. So you may notice so far we haven't declared anything as being public, private, protected, friend, whatever else. And so that's because you don't really have that in Python. Most things are just public and you can just dive in and use them. I won't bother going through this whole example, I don't think. But what you can do to make it sort of hide it away is you can put double underscores in front of things. So like one underscore means it's protected and two underscores are private. And then the IDE and Python actually renames the method slightly. So that's what stops you from calling it because it doesn't have the name you expect it to have. But you can still call it. So I think it renames it to be something like business logic underscore cache. So you have to make an explicit effort to call this private method.
are IDEs intelligent to pick that up? Because when I was doing it before, it's more like Pirate's code. That's like logic of you can develop it in that way, but there's nothing stopping you.
Yes, that's right. Yeah, I think it's more of a convention than I think you can. Yeah. I think some bits it will. I think. See if I can remember. Yeah, I did say it doesn't work there, didn't I? Yeah, so there, for example, I'm trying to call this internal method add to cache and it can't find it because it says it's got no attribute called internal. Add to cache. But I think if you look at so you can do dir on an object and it'll show you all the available methods. And you can see here it's renamed that method to be underscore business logic add to cache. And does it let you call that? I can't actually remember. Yes, so it ran it. So it complains in the IDE, but we'll let you run it. So it's more like a convention. You shouldn't be doing this, but we're not going to stop you. Which, to be fair, with reflection, you can do in C# as well. So. Yeah. Yes. Yeah. So you've got dir, which is like doing reflection. It's sort of the equivalent. Yep. Okay. So hash sort of if directives. So this isn't a thing at all in Python because you don't need to do hash if because what happens is when you import a script, it runs it there and then. And by running it, I also mean creating functions, creating classes. There's just commands like everything else. So this is quite valid. So here I'm saying, if name equals David, I want to declare the function looking like this. Otherwise, I want to declare the function looking like that. So it's just going to run, as it imports the script, it just runs it down, it gets to this point, evaluates name equals David, which is true, so it's going to declare it like that. So it's no different from running any other code, creating a function or creating a class. Which gives you sort of the same power as if you're doing hash if in C#.
How many times would it be executed? So let's say you've got a script that's importing a module of a different file and you've got multiple of those. Is it run once and then cached for every import, or is it run once for each import?
It's, I believe it's once overall. I think it's just the first time. Yeah, I assume if it's two physical different, so say you've got two packages that both use the same file, I assume each package then runs its own one. But
so it's a bit like how Node does its package management and module resolution then.
I haven't used Node for years, I can't remember, I'm afraid. Yeah. Yeah, obviously this type of thing can catch you out though. So yeah, in fact, it definitely is once. If you do something like you declared a dictionary or something at the top of your file and you import it, then obviously as it ran the first time, that dictionary then gets initialized, and then you may then expect that to be imported the next time you call that script, but because it's already been imported once, it won't get initialized again. So it's like I guess like static variables. So yeah, so creating classes. So we looked at init before on a class. Something else you can do is new. So in this case here, I've got two classes. I've got a class which I'm calling missing house, which is just going to, if you do print missing house, you get there isn't a house. Or another version of house, we can give it an address. And if you do print, it's going to tell you the address. And then we also have our sort of base house, it's like factory method in effect. Again, this is a very sort of contrived example. So we can also overload the new method. So the new method gets called before that class is created. So we've got some control over how the class is going to be created. So this is a very sort of simple example of that. So when I create this new base house, I can pass in an address. And if I haven't got an address, I'm just going to return, if I have got an address, I'm going to return the version of the house which takes an address in. Otherwise, I'm going to return a different class, which is missing house. So even though I'm creating a class called base house, I can get back one or two other classes. And so...
Do house and missing house have to be derived from base house?
No, they can be completely different. And in fact, they are, because if you think...
Base house is a factory.
Exactly, yeah. Yeah. So you can do a lot more powerful stuff with this, which I've never done it, but you can sort of get the idea that you can sort of hook in quite early when classes have been created. Yeah, so then down here I'm just showing the two examples. One, once I give it an address, and the second time I don't. And then, yeah, you get the two different print statements from the different classes. Right, so that was it for those. Right, yeah, so that's the basic sort of language we've touched on. I mean, there's other stuff I can go into if you want, or I don't know what else you want to see. I mean, web servers and stuff like that. I can show you a simple web application if that's interested, or performance, or I don't know if anyone's got any topics in particular.
Quick question back to the typing before.
Yep.
So like in C# you quite often have methods where the top of the method you might go is value not null or parameter not null.
Yeah.
I mean, is there something similar in Python for those and sort of like the type checking? Is that kind of like a pattern that people use where you go, I put my markup on there to say give me a string, but people can still pass in a number. But you might put some like debug checking in there to be like, actually no, you give me an integer, I'm going to fail early rather than calls or something.
Yeah, exactly. So how should we do this? So we say A is an optional string. A dot to upper. Oh, upper. Yeah. So here it's hopefully this example is going to work. So here I'm saying Yeah, so A can be a nullable string, and it's failing because it doesn't allow me to do A on none. But I think what you're saying, if on the line above I did something like assert A is not none. Yeah.
So the assert keyword is part of the Python language then?
Yeah. I assume you can do it.
What happens if it fails the assert? Does it throw an exception?
No, it didn't, did it?
A wasn't. If A was
Oh, A is not. Oh,
or
A is not none, but A is
yeah,
none.
well, if it is none, yeah.
Did it throw it?
I think you probably defined A as a list somewhere else. And it's just
Yeah. Let's try ABC. I would. Oh, has it already? Ah, yeah, because it hasn't got a value. That's why. Yeah, you're right. It's because it's declared further up. Yeah. Yeah, you get an assertion error.
Search. Which I suppose is that an error or is it a kind of exception?
Yes, an exception. Yeah. Yeah. So. Yeah, we tend to put those in sort of the unit tests as well. So there's different test frameworks, and some you just use assert.
Yeah, but you can have an assert in code as well, can't you?
Yeah, well, yeah, which is what that is. Yeah. I don't know because in C# we obviously have debug and release, and I think they get removed from release builds, don't they? I don't know what happens in Python about that.
Probably, yeah. Possibly.
You can technically compile Python bytecode in an optimized form, which will remove some of these asserts.
Okay.
But no one ever does that. So they stay as just runtime asserts.
Yeah, and I assume.
There used to be published letters for version of Python that were basically called C, and then we'll just compile C.
Cross compiler.
Still have it.
Yeah.
.NET,
That was
yeah.
discontinued a long time ago.
I think we go. I think there's a bit.
No one is very good at alternative Pythons because Python just doesn't jit very well.
Yeah, instead of doing assert, you can just use an if as well.
What do you like and not like about Python? I'm curious about.
I've wondered that. We're on video though, so I have to be careful what I say.
Just a video.
No, I mean no. I like sort of the ease of coding in Python. Performance tuning is a complete pain, but I do like the speed you can write code and with the typing hints as well. I think without typing hints, it's a bit rubbish if I'm honest, but I like the type hints. Given a choice between C# and Python, I'd probably pick C# if I'm honest. I don't know. I've always liked the optimization side of things, and I find that quite hard in Python.
And Python is quite hard to write unless you turn on every single check you can think of. So it's like use my file restricted settings, use all the linter type.
Yeah. But the problem is if you turn on, it's the same with TypeScript in that, I guess. In that you turn on all the linting settings, everything, and then all the third-party libraries just come up with red error messages because they don't support types.
And then stub them all.
Yeah.
You don't end up saving very much time over stuff in type language once you've added all that.
Yeah. But I mean, I do quite like the syntax, and the list comprehension's nice. Yeah. Unlike you, I quite like the indentation and not the braces, but
It's each to its own.
yeah.
I think a lot of it is what language you used yesterday.
Yeah.
And if you're switching between them, then it feels awful.
Yeah.
Because now you're thinking in terms of curly braces.
Yeah.
If you've been using JavaScript and TypeScript and C#,
Yeah.
and then now it's a different
Yeah.
block definition syntax.
Yeah.
You've got to just kind of every step of the way you're kind of having to remember. No semicolons.
Yeah.
Today it's no semicolons. Yesterday it was all.
Yeah. Yeah, and
I forgot the semicolons. And so.
Yeah, and probably somewhat evilly, I don't bother putting semicolons in JavaScript anymore because
Oh, that's really bad. You rely on automatic type semicolon. So you've got an NPSR.
yeah, I know.
I think that's bad.
Yeah.
Sorry.
Oh no, right. Yeah. And I guess the other strange thing maybe is like obviously in C# dependency injection, all that sort of stuff's a massive thing, and it isn't in Python, or
Yeah, it's
certainly not how we use it.
JavaScript as well.
Yeah, so it's strange how different things are important in different languages.
In C#, any kind of testing is a pain because everything's kind of restricted, isn't it? Well, it's by design. You can't get at things.
Yeah.
That's the way the language is designed. But you want to get at things to test them.
So testing's quite. Yeah, so we obviously try and test as high up as we can, like API level, but then it's also quite easy to do this, dive in and just mock out a little function deep inside. Yeah.
I guess have you been using Python for web stuff?
Yes.
That's the most common thing it's used for. So did you find performance okay?
No. Yeah, I'm certainly not going to argue performance is good, but that's not our, as a company, that's not our biggest concern. So we do data science stuff for construction projects, and so the data science stuff's far the bigger chunk of code, and that's, we're not going to have 1 million concurrent users and things like that, so that's not. The website's just a way of visualizing the data. So I can show you a web server. So that's our web server here. So there's a couple of common frameworks. The one we use at work is Flask. So you install packages. There's something called pip, which is the package manager. So you do pip install Flask. Import it to say you can use it, set it up, passing the name. And then you can just get down to declaring your methods. So it's like other sort of minimal languages. You can say, if I'm hitting the home page, so the root / it's going to call this method, and I'm just going to return the body and the response code. So that's, and then to run it. So then, run it, starts the web server running on port 5000 by default. And there we have it. So if you want to do something fast and simple, that's all you need to do to get going with a web app. Obviously in the real world, nothing's that simple. And then if you want to do something more complicated, you've got other methods like, you can return the content to the file. So like a fav icon, for example. You can return things as JSON as well. You can pass parameters in. So that root here, we're going to call, so web page / JSON / a number. And then that comes in as a parameter to our method. And we're just going to return that as a JSON blob. So we use Flask for just APIs. So all the sort of the rendering, all the other stuff's done in React anyway. So we only ever just return JSON from methods. But it's also got things similar to Razor Pages for Python as well. And loads of different libraries. But it's never going to win in sort of performance contests and stuff like that. Anyone's got any questions about web stuff? There is a WebAssembly version of Python, I believe, but I haven't touched that. But I don't think it's anywhere near as mature as Blazor or anything like that. What else we got? We're talking about imports and packages and things. There's two ways of importing third-party libraries. You either do import and then the name of the other file or the package you're using, and then whenever you reference it, you do file1 dot that method name, or you can import from a package a particular method, in which case you don't need to prefix it with the package name. And then if you've got a collision between two methods, you can rename as well, so you can say as like X, Y, Z. So that's all pretty straightforward. And file 1 just contains, yeah, just our method. So again, when we import that file, it gets ran. So if there's an error at the top of the file, so 1 divided by 0 error, for example. Yeah, it fails because it's importing a file which in turn has got an error in itself. So the main, so the main reason a lot of people use Python is for the data science libraries, because there's got quite a lot of those built in. So pandas is quite a sort of common one, which is like it's basically a wrapper over the top of a multi-dimensional array. So it gives you sort of loads of extra methods. So for example, so I've imported the pandas library, and everybody always just renames it to PD. So, and then you've got methods like read in a CSV file, you give it a CSV file, and then you do .head, which will then display the first 5 rows in that CSV file. As you can see there. And then you've got loads of other commands. So once you've got your data, you can then manipulate it. So for example, here I'm renaming some columns. Oh, sorry, this one first. I'm adding a new column with a calculation, so then that gets applied to every row. So a bit like a spreadsheet. So you can see an extra columns appeared, which is wrapped around. You can rename columns using .rename. And you can also plot stuff in pretty diagrams. So you see, so for doing data analysis, it's great for this type of stuff, because you can just load in your data, play about with it, shape it however you want, and then dump it out on the screen. So you can also use something called matplotlib for plotting stuff. So here I generate 10,000 random numbers, and I'm just going to plot them in a histogram. So as you imagine, it's nearly a straight line. That's probably that. So a lot of these libraries, although we're calling it from Python, are actually written in C, because for sort of performance reasons, because it can be quite intensive. So pandas is one, and NumPy is another one, which is gives you an array, which is very fast to do operations on that, and a NumPy array as well.
Yeah, you wouldn't want to be writing this stuff in C, would you? Like this?
No.
I mean, the top level.
Yes. So yeah. And then sort of the last section I've got is just a bit about performance and probably why performance is rubbish, really. So I'm trying to remember what I did here. So here I'm summing the numbers from 1 to 1,000. So there's a few different ways we can sum these numbers. We can do a while loop. So we start off with 1 and result of 0, and we just loop round adding up the numbers. We can do the same thing with a range operator. We can also use list comprehension. You see here, so that's going to give us back our numbers from 1 to 1,000, and then we can just call sum. So they should all do the same thing. And then, and then there's a NumPy, which is the package I just mentioned, which is the fast sort of array, a C sort of array package. So you can do np.sum as well. So we've got the different versions we can call. And then we can also time them. So the built-in time it function will call each of those methods 1,000 times and give us our times. So if we run that. We've got some weird race condition then. Anyway, hopefully you can see from these numbers, we get the same numbers each time, which is good, but there's a very different in the speeds. So the NumPy version, which was version 4, wasn't it? Yeah, that one. It's a lot quicker. It's like 10 times quicker than some of the sort of proper Python.
Massive difference.
Yeah.
Massive. Orders of magnitude.
But, in fact, was that version 4? Yes, sorry, I understand what's happened now. Yeah, forget version 4 for a second. Yep. So they're the first 3 we did, which and the NumPy one's the quickest, and then that's half the speed of the first one we did. But the trick to performance tuning quite often is just to get a bit cleverer rather than just doing something like that. And if you're just adding together numbers, you can just use maths. So that's the formula for adding together a range of numbers, which is version 4. And you see, doing it intelligently is going to beat it by miles, whichever solution you've got.
You mentioned in NumPy that a C library, so can you do interact with import like C libraries and call those?
Yeah, I've never done it, but yes. And I was looking at this last week. I think you can also extend the language as well by adding. So when you look at, there's a method called set.intersection, which you give it 2 sets, and it will show you everything that's in common those 2 sets. And you can see the source code for that, which is written in C. And I think you can sort of take that and do your own versions of it and import that C library in as well.
Does it do, if you take the stuff like your NumPy and things like that, does it do that stuff faster than it does it in C#? Because it's got underlying stuff written in C, or is it similar speed at that point? I just know, I'm just referring to like some of the things where we're doing advent code.
Yeah.
When we're doing performance tuning.
Yes, there's some things where I couldn't get close to your solutions. Yeah.
But there's certain things which do get close.
Yes, and but I think most of the time it comes down to getting smart rather than I mean, here's another good example. Which so here what I've got is I've got a list which has got 10,000 days in it, and I want to add 100 Bs to the end of that list. So so we noticed last week at work, my boss, he's always been writing it like that, and I've been writing it this way, where instead of doing plus, I've just been doing dot append. And we both assume they're the same thing, and so we're going, well, which is the best style? We don't know. Maybe that one, because it's really what you're doing, and that's like mutating this list in memory, and that's a bit weird. So then if you time the two, so both doing exactly the same thing, adding 100 elements. You can see one is like 0.3 and the other one's 0.04. So it's like, so it's things like that. So it's just a question of understanding, what things are slow and what things are fast in Python. And then when you start to think about it, it makes sense, because here we're appending to a list, and a list is, a wrapper around an array, and an array's got free capacity anyway, so it's not having to do any sort of memory allocations or anything. But until you try all this sort of stuff out, you don't really have a clue what's fast and what's slow.
In the first case, are you actually creating a new list?
Yeah, every time, yeah. Yeah, I mean, these things tend to be obvious once you know them. But it's just,
I suppose there's still stuff like that that's relevant in C#
Yeah.
as well.
yeah,
Like the conversation around dictionaries and lists.
yeah,
Like work with big lists in C#, you'll notice if you could have swapped to a dictionary.
yeah,
Well, sometimes if you're using a library, the authors of the library are being under time pressure. Get it as fast as you can for this demo case.
Yeah.
And so they optimize it for a certain size of elements or something.
yeah,
It would be ordered something. And then if you go over some limit, it'll flip over to some other algorithm.
yeah,
And then the performance really changes suddenly and arbitrarily when you hit some limit, because that's the way they've coded it, because you're using, you're not really seeing the code, you're just using a function.
yeah. So sort functions are a good example of that, where they can switch depending on how much data you've got.
Yeah.
Final example then. So here, I was just playing about this yesterday. So I've got a string which contains A, B, C, D, E 1,000 times. So it's like 5,000 characters long. And I just wanted to see what was the quickest way of counting how many capital A's we've got in there. So first version, just loop for each character in the string. If it's an A, increase the count by 1. That seems fairly efficient. Couldn't think of a quick way of doing that. And I thought, well, maybe doing an iterator slow, maybe some sort of like array lookup where, you count from 0 to the length of the string, and you say, is that element an A? If so, I'm going to increase the count by 1. Maybe that's quicker, because that seems quite fast, because I'm indexing into an array. And then another version was, you can also do a bit more Python-y, so we can do list comprehension. So for each character in that text, if it's an A, return a 1, and then we'll just add them all up. Or another variation of that, return a 1, but just count how big that, well, put it back into an array and just count how many elements we've got in that array. So we can return all the ones which are A's, in effect. So again, they all look fairly similar. Or we could use the counter class, which is one we saw earlier, where you give it some text and it gives you a dictionary. But that's going to count up all the A's, B's, C's, and D's, and E's. And we only want the A's. And there's also a method which is .count, where you say, here's a string, just count me how many A's in there. So here's an example of like, well, I've got no idea which is quickest. If I had to guess, I'd say probably that second one quick, because you're just indexing an array, and probably that's quicker than that, because here we're creating an array and here we're just summing up some numbers. But if we run them, so the first two are finished. So our quickest one is our built-in method, which is .count how many A's. So there's 0.03. So looping over our array, indexing into each element is 0.4, which is like, the second slowest, isn't it? And that's like the code you think would be quickest. That 3.31, yeah, but only one version. The version that doesn't create the array, but just does a sum of a load of numbers, is a lot slower than this one. So
Surprisingly, the one that's creating another array.
Yeah.
Is still slow.
Yeah.
The one, version 3 is actually creating a generator rather than a list.
Yeah, so it must just be the fact it has to go with that generator. But I just assumed it'd be like IEnumerable, where it just it's next until it gets a stop exception. Yeah. Yeah.
So the fastest one was the counts function.
Yeah, so the fastest one is the one that's using yeah.
It must only be counting the A's then.
Yeah, so the fastest one is this one here, which is yeah. So which is what you'd think, if you're going to write that yourself in, well, C#, for example,
Yeah.
you'd probably write it, something like that, wouldn't you? Which
But presumably that's because it's part of the language and it's probably written. It's a language.
yeah, it is in C, yeah.
So it's just back to the start about whether it's compiled. Is it compiled, or is it partially? Is it tokenized, or is it just interpreted?
It's interpreted as far. It sort of compiles to bytecode, I think, and then does something from there. But
we're in Jupyter,
Yeah.
aren't we? So that's probably interpreted. But if you
well, we're not here. We're back in Visual Studio Code. Yeah. Well, there is one. Yeah.
So if you give it a .py file, it will under the hood immediately compile it to a .pyc file.
Yeah.
But that's just turning into bytecode, which is then interpreted. And the bytecode is a very thin wrapper, or very thin lowering of the syntax.
Yeah. So
It works like Java then, where the more time you run something, it's all.
No, there's no JIT compiling inside it, so it just interprets it. There is a separate,
yeah, I was going to show that. Yeah. So instead of using, so that was C Python we've been running, which is like the standard and implements everything. There are different versions of Python, so one of them is PyPy. So if I run that same set of 5-6 examples again on there, you can see you get very different results.
very different.
Yeah.
They're really slow functions.
Now,
not so
five
slow.
things.
Yeah.
So what's the difference between that one and the one you were doing before?
So this PyPy is optimized for speed, but it's not 100% compatible, so you can't do everything in it.
PyPy is a JIT compiler.
Yeah.
Huge difference in performance.
It's good for advanced code stuff though. But yeah.
5 is almost identical between the two,
Yeah.
whereas the others are.
Well, 6 I guess is the
6
same.
is
That's
slightly
a
slower.
statistical difference, isn't it? But
1 to 4 are all very fast.
yeah. Right. So unless anyone's got any questions, that's probably the lot.
When you're doing builds, now, we've been doing little bits of code, and
Yeah.
that's great. And I can see how, that'd be quick once you get used to the syntax, and that's not, you wrote that, and you're solving these problems. But when you then start writing the 10,000, 20,000, 100,000 lines of code,
Yeah.
how do you find Python as at the sort of enterprise coding level? Because some languages kind of fall apart a bit when you go.
Yeah.
Like Perl, for example, springs to mind.
Yes. So
Does it get more complex?
it does, but I think it comes down to how you structure your code anyway. So the way we've got it is, so our API project's our biggest part really, and so we have different folders for different features, which then group together APIs, and then so if you're working on the customer's feature, for example, or customer's API, you're in that one folder anyway. And then I find Visual Studio Code very good for searching for stuff, so I find that fine as well. So.
So you're kind of modular on this.
Yeah.
Your design.
Obviously, the thing you don't get, which you get in C#, is if you refactor something, like you rename a method or add a parameter to a method, and you forget to do it somewhere where you're going to call it, you're going to get a load of compile errors by default. In Python, you have to run it through another tool to get those errors, and unless you've got your typing right as well, it may miss them as well.
So
in some
you
cases.
haven't got you don't have to have the benefit of strong typing, but you've got tools, links,
Yeah.
and test suites and things
Yes.
to compensate
Yeah.
for that as you scale out.
Yeah, but where in C#, if you've got decent unit tests and the compiler's so good, you can refactor quite happily, and it sort of feel like a bit like a low risk exercise where
You can just change the name of your function.
Yeah.
Error chase, really.
Exactly, yeah.
What about if you're using something like
I mean, you do get tools like that in Python. They're just not as
if you use
comprehensive.
something like, is it PyCharm or sort of like one?
Yeah, I haven't used that. I've just been using VS Code, but
I use PyCharm.
yeah.
Then does that give you better refactoring and stuff? Like,
The JetBrains stuff normally does.
Yeah.
It's not super smart. I mean, the trouble I have with Python is I don't use mainly C#, but if somebody sends across some code and I end up 5 folders deep, they've all got init files, you're digging down all this boilerplate just to get to the bit that you want to look at. And then if you refactor in any function names there, it won't pick it up.
Right.
Yeah.
But that might be my bad use of Python more than.
I use it similarly bad in that case, I think, yeah. Yeah, there's weird things. When you have another folder, you can sort of have it as like a submodule, and you have an init file, which then tells it it's a submodule, and then, the naming all changes. And yeah. But I think as long as you structure your project quite well from the beginning, it's okay. So I find it easier than something like F# where you have to physically have the files in the right order and things like that. I find that a bit more confusing.
Do you see any problems at work with using jigs and notebooks, given that there really are spreadsheets of Python programs?
We're a small team, so there's only 2 of us, so we don't have too many issues like that. So the idea we have is we write the code as sort of classes and modules, not in Python. We then consume those from the notebook so we can test them out and play about with them, visualize the data. Because testing when it comes to data science is a bit different, because you can't just write a unit test and run your data science code. It's all a bit fuzzy, and so you have to sort of play about with it. And then once we've got it working, we then take the notebook and put it back into proper code with tests. So that seems. We certainly don't use the notebooks in production. We thought about it, but no.
I've advertised notebooks in the past, and then I just sort of told you to go and run the notebook and
Yeah.
add the new notebook file to the hard drive.
Yeah, we looked at that and then thought, it's quite nice having tests and stuff. So. Right. Is that it? I think. Right, we're probably done in that case. Right. Well, thank you all for coming. Hope you found that useful.